All right. Welcome, everyone. My name is Bryson Tyrrell, and this is Supercharged CI/CD with GitHub and AWS, the extended edition. And yes, I wanted to play the music when that happened, but I decided that was too much of a hassle. All right, so this presentation I actually delivered 2 weeks ago at Mac DevOps, and I decided that I was going to pitch the same talk for this conference, except because that one was 20 minutes and this one is 75 minutes, I would take all the high-level content that I did for them and throw in a whole bunch of YAML to fill in all the time gaps. So strap yourselves in. Yes. So CI/CD, what is CI/CD? Raise your hand if you feel like you have a pretty good understanding of what a CI/CD process and pipeline is.
Define pretty good.
Do you feel pretty good about it? There we go, yeah, a little bit of that. So CI/CD, it is actually 4 words. So continuous integration. That is the practice of integrating changes frequently and ensuring that code is in a working state. Continuous delivery is the practice of automatically releasing those code changes all the way to production. And these two things together form the CI/CD pipeline. So, I did the part about what I did back DevOps a little too early there. I forgot about this slide. So what this presentation is really going to get into is there's going to be some high-level bits where we're just sort of talking about the CI/CD process, and then there is going to be a lot of YAML interjected, which is actually the implementation of some of these services on the GitHub and AWS side that we use to make all the magic happen. So I debated about moving this section, but I decided to keep it in place. It's kind of important to understand how we can securely have both service providers working together and talking to each other, and how that impacts decisions you might make when you're implementing your own CI/CD pipelines. Raise the hands in here. How many people are GitHub users? That's not surprising. How many? What's that?
Former GitHub.
Former. Well, you still count, Tom, I guess, maybe. I'm sorry?
We just moved to GitLab.
I know, I'm sorry. This is off to a great start. Anyway, how many here are AWS customers where you are actually putting things in AWS even though your code is in GitHub? Handful, not too many. So I think you're going to find some things about this will give you ideas. CI/CD pipelines are not here's how to do it. It is a process, and then how you achieve it is going to be a combination of different things that are, what do you have access to? What are you actually using? Where does it need to go? So all of this is just to give you ideas. I'm not telling you how you're going to go back to your businesses after this and maybe start implementing things to get to that point where you have a continuous pipeline. All right. And the reality is, if you are looking at, okay, I want to do CI/CD and I want to have a pipeline in place so that I can automate a lot of this stuff, you don't need to use both things in conjunction with each other. You could achieve the entire pipeline with just GitHub Actions, which a large portion of this talk is actually going to be talking about in detail, or AWS services. You could potentially do it with both of those, but if you're using a combination of things, then it's likely that you can find a mix of things together and approaches that will give you the best trade-offs for your own experience as the engineer and the system administrator trying to achieve this, and then also security. So I think it's safe to say that for the rest of this talk, we'll assume that everyone is using GitHub for source control, except for Tom, and you're probably not using AWS's offering, which we'll cover a little bit coming up here. And while this is not actually inside any of the examples today, one big piece of interoperability that does exist is webhooks. So any event that's happening on your repositories, whether that's pushes, commits, new branches, changes, deleted branches, new tags, edited tags, pull requests, all those things are events that can emit webhooks. You could have services in AWS receive those webhooks and then make return API calls in order to go do something in response. None of the stuff I'm going to cover here for scenarios gets into that, But this is something that teams that I've been on in the past have used for when we were getting a little advanced into pipeline management. We would rely heavily on webhooks as an integration point, so that way when we had repositories coming online from our team or other teams, we could automate a lot of this CI/CD process with setting up all the boilerplate. But it's something to always keep in mind that like this is an avenue for you to be able to build automations around your release processes. The big thing is OIDC, OpenID Connect. So with GitHub and with AWS, you can set it up so that GitHub is able to assume roles in your AWS accounts and get short-lived credentials and then not actually store passwords or tokens that have long lives in GitHub secrets and then having to remind yourself on the calendar to rotate those things regularly or set up whatever kind of automation to try and rotate all those things. They have already solved this. It's not an AWS specific solution. You can set up OIDC Connect with other platforms as well. But I'm going to give a quick explanation of how this works because it's very pertinent to some of the things we're going to talk about here. So the first step when it comes to the OpenID Connect integration is you're setting up a trust in your AWS account. So this is where you go to the IAM console. There is a section for it for adding trusted providers. And then it's really well documented on the GitHub side. This establishes GitHub as an external identity provider that is allowed to assume roles within your account. And then once you have done that, you're then able to craft IAM roles with trust policies that state the conditions for which, yes, this token from GitHub has a valid signature, and based on the claims in here, it is allowed to assume this role, and I will give back temporary access credentials. It's a really slick and really secure process, and I'm not going to get too much into the weeds of it, but I will have documentation links later that can point you to the process. So once you've done that, then inside GitHub Actions, which we'll be covering this in more depth in a moment here, you can make it so that your action has a setting to request an ID token. And then that will tell GitHub, okay, GitHub Actions is running. It wants an ID token. I will sign one that contains all the claims for the workflow that's running and like what triggered it and all these other details. And then the workflow will call this API, which is actually called STS Assume Role with Web Identity. This is your action calling out to AWS, passing that token, saying, I want to assume this role and get temporary credentials. AWS will then take that token, unpack it, verify the signature back with GitHub, look at the claims, verify the claims against the trust policy of the role that you are trying to assume, and if all those checks pass, it will then generate the access key ID, the access key secret, and the session token, and send all that back down, and now you're going to be able to use AWS command line tools, AWS SDKs inside your running GitHub Actions. So the extended edition begins. This is an example IAM role as a CloudFormation template. And this piece right here is that trust policy that I keep mentioning several times. So action, it's allowing the API call, assume role with web identity. The principle there is GitHub. So GitHub, that trusted third party that we added into IAM. So we're saying that they're allowed to assume this role. And then down here in the conditions, we can see that it's looking into, this is the syntax for going into the token to specific claims and then matching on those claims. So what's going on here with this subclaim, the subject claim inside the token that GitHub signs actually contains the ref for what triggered the workflow in the first place. So in this case, this policy statement says that for the my repo, I'm sorry, it's very terrible, only the main branch, only workflows that were originated from the main branch are allowed to assume this role. That's pretty powerful because if you want to scope down access controls to AWS resources to GitHub Actions and say that like, well, I only want things that have actually made it to the main branch, triggering a workflow to actually be able to touch these more sensitive APIs or resources, then like I will make it so that only actions triggered from that ref can do that. And you can also change this up and switch this. So instead of the condition there where it says for all values string equals, you can swap that out for all values string like or for just string like, and then put a wildcard in there saying that like any branch in this repo can assume this role. Maybe it's a less sensitive role to some more general resources that are used as a part of a test or something, or just grabbing down resources from an S3 bucket maybe that all the branches should have access to. But you are able to very tightly control what GitHub Actions can assume what roles. And then you just plug in all of the permissions that you want. This one in particular, this policy grants only upload rights. So put object to an S3 bucket at a very specific key path. It doesn't allow you to upload any object you want, just this one, which I'm going to explain why that is much later in the presentation that I'll click. So let's dive into GitHub Actions themselves a little bit here. Who all here has used GitHub Actions? Ooh, you're all in for a treat. So this is a service that allows you to define workflows that run in response to things happening in your repository. So you know how I mentioned webhooks, and that's where GitHub signals an external provider. It's actually the same thing under the hood with Actions, where for any of those event types, you can trigger a workflow. And then in response, it's going to go through YAML files that are stored in your repository at .github/workflows. And then if they match the event type, it'll run them. So by default, GitHub Actions workflows, they run on compute resources that are provided by GitHub. But one really cool superpower of this service is that you can tell it to use compute from other places. These are custom runners. I'm sorry, I'm not getting into that today. I think there's like 3 talks at this conference about GitHub Actions. Maybe one of the other 2 get into the custom compute models and how to use those, maybe. But like, if you need it, you'll know you need it. And it's there, and it's a great tool to have in your tool belt. So, how do GitHub Actions work? Well, like I just said, in response to a triggering event like a commit or a push, as GitHub refers to that as, or even a pull request or whatever, GitHub Actions is going to kick off the workflow. Then your workflow is going to run one or more jobs, either consecutively or concurrently, because you can configure and control how that operates. And then each one of those jobs is going to run a number of defined steps. And those steps can be all sorts of different kinds of operations. You can have command line tool calls. You can actually use Docker images as a step action. And then you can also use actions, which that's not confusing at all to have GitHub Actions and then use steps, but steps can be actions, whatever. But what the actions are going to be is they're going to be pre-composed workflows that are publicly made available on GitHub's marketplace, and you can just grab something somebody else has already done, plug it in there, and you save yourself a whole lot of work. There is a huge amount of customization that you can do in GitHub Actions. And really, GitHub Actions should just be a workshop at this conference because there's so much that you can do with them. So this is an example action. This is actually the GitHub action file that's up on GitHub's documentation. It's their hello world example. At the top there we see github.actor. That's actually a reference to the user that triggered while the workflow was running. And then the on is where you define the triggers. So in this case, this one says on push. Any type of push in this repository will trigger this workflow run. And then this section right here defines those jobs. And you can have multiple jobs. Those jobs can be set so that one can only run after the other is finished, or you can set them to just run in parallel. Choice is yours. And then this runs on is where you define the compute type. So this job uses Ubuntu latest, which it's going to run on GitHub's compute, and it's just going to grab the first available slice of compute out there that has this Ubuntu latest label. So this action is going to run inside a Linux environment. You can add more labels to more narrowly define that. Like it's all additive. Like if you have multiple labels on there, it's not like if it matches any of these, you're scoping down the type of compute, because you could say Ubuntu latest, but it has to have GPU compute, so you throw a GPU label on there. And there's a lot of other things that you can scope that down to, ARM, x86, et cetera. But you could also, instead of Ubuntu latest, you could also do macOS and Windows runners. Very important if you're doing code across multiple platforms as a part of your job. And then inside each job, you can have as many steps as needed in order to complete whatever that job is. And these steps are sequential. And this job is actually using a combination of official GitHub actions. So you see that actions prefix there. That's GitHub's space. They own the actions prefix. So anything that's prefixed with actions, that's an officially supported GitHub one that's made available. And the checkout and setup ones are kind of ubiquitous. Like they're used in almost every single job that you set up because you want to grab in a copy of the code at the commit that triggered the thing in the first place. And then you're probably going to need to set up a runtime in order to test that code, or then install some tools on top of that runtime. And then the last two there are just running shell commands. Like the run key is going to be a shell command that you're now running inside whatever this runner is after like it's done these initial actions. So in the AWS arena, their CI/CD tools are spread out across a number of different developer services, but they all integrate together pretty tightly. So code commit is an aptly named Git repository service. I did allude to it earlier. And then code build is AWS's build system, and it's also very aptly named. It operates very similarly to GitHub Action, to like a GitHub Action job, I should say. With code build, what it looks for is it's going to look for a build spec file. So a build spec.yaml file that's at the root of whatever was handed to it to go process. And then that build spec file, though, is sort of defined in just 4 phases. And those phases can be the install phase, which is meant to sort of configure the running environment, the pre-build, where you're prepping content may be necessary for the build step itself, and then the post-build if there's anything that has to happen after that. And really, you're going to be running sort of like scripted commands in each one of those phases. And we're going to see examples of build specs later on. Now, code build is really divided into 2 parts. So you have the build spec file that I just mentioned, but then you also have the code build project itself. And the code build project defines the running environment that's going to process that build spec file. So this is a minimal code build project that's in a CloudFormation template, just like that role we looked at. So down here in the environment settings for this project, pretty self-explanatory actually. So it's going to be a Linux container, build general 1 small. There's a documentation page that explains the amount of CPU and memory that each one of these labels has allocated to it. So like a lot of build jobs that I've done over the years, like I always stuck with the smallest one. I didn't need a lot of compute, and you can save yourself a couple of bucks. And then like there's a bunch of built-in image or provided images that AWS gives you in order to have ready-to-go build environments. You can also point to external repositories or your own repositories in, say, Elastic Container Registry. But like this is also very, very customizable. Just like how I mentioned with GitHub Actions, like you can like go pretty fine detailed on like the compute and like using other compute types. With code build, like that one change right there where I went from Linux container to ARM container, I just switched from an x86 build environment to an ARM environment, and still using all the same options, except the image is now pointing to a ARM one. And then this was a recent thing, and this is really, really cool. Code build can now just use Lambda. So if you have builds that don't need to last longer than 15 minutes, and they don't need a lot of the heavier like amounts of CPU and memory that you get from just the standard like container formats, like fast and cheap build jobs in code build is kind of awesome. And I still need to dig into it, but I know people have gotten GitHub runners working using code build, which is using Lambda, or just straight up using Lambda. So I mean, like, the space is kind of crazy as to how to actually do this, and it's all about like how do you do things fast and cheap. I sort of like skipped right over this bit right here. So code build, when it runs your job, it needs to have an input to it, and it needs to be able to send the output of the job somewhere. And you can run code build by itself, but generally it's part of something that's going to be orchestrating it. In this case, that's another piece of the AWS tool chain, which is code pipeline, which you might sense that there's a naming pattern to the developer tools in AWS here. But this is a build and deployment orchestrator. So code pipeline, again, like you're going to see similarities here to like what we just saw with GitHub Actions. There are stages within code pipeline, and then there are going to be actions within code pipeline, which can be in parallel or in sequence. And then when that stage completes, it moves on to the next stage, and so on and so forth. It's also responsible for taking artifacts that are outputs from each one of those actions and then passing them along to the next ones for you. So generally, with code pipeline, I've not actually seen an example of code pipeline not using S3 for artifacts. Like I have not personally seen it. All my pipelines I've ever set up over the years, we just used S3 for artifact storage. So whenever a stage or whenever a step completes an action and there's an output artifact, like in the background, it's saving those files in S3 and then it's retrieving them to pass on to whatever service is next in the chain. So first stage here usually is always going to be the source stage. And in the source stage, this is where you define triggers and places where it's going to pull in files. Not every source needs to be a trigger, but then when your pipeline runs, it's always going to pull in whatever it's pointed at for that source. So you can have one or multiple sources. One of those could be a trigger, all of those could be a trigger, but all of those are going to output an artifact. It's going to get stored, and then you can move on to the rest of your pipeline and then pass those artifacts to other pieces or to other stages, like the build stage here, which this is what's calling that code pipeline or code build project that I just defined. And by default, code build will look at the root of whatever artifact it was handed for that build spec file. You can override it and tell it, okay, you're going to run in code build, but this is where you're going to look for the build spec file. So you can set up your repositories with multiple build specs, which each do different jobs. And then you can call code build as many times as you want and just set it to run different build specs. You can also, if you have to do cross-platform stuff, you can have projects for different compute types that either all use the same build spec file or use different versions of build spec files in order to actually build for Mac, Windows, Linux, whatever. Okay, so now that we've covered sort of interoperability between GitHub and AWS, and we've sort of covered the services that we are going to be looking at when it comes to exploring a CI/CD pipeline. Now we're going to talk about the pipeline itself, meaning the CI/CD thing, not like just all the services that I just did here. So there are four phases when it comes to a CI/CD pipeline. First is your source code. Then you're going to build the code. You're going to test the artifacts from that build. And then ultimately, you're going to deploy those artifacts. And now to truly be a continuous integration and continuous delivery pipeline, that entire process has to be automated with ideally no manual steps happening along the way. Automated is automated. Once your code passes like the first check, it starts to go through that automatically, and if it passes every step along the way, it's now in production. So we're going to dive into the source control aspect first. So source control as code, configuration as code, infrastructure as code, code as code. What? It's code as code. CAC. Who all here is doing like configuration as code that's not Tom? Cool. How many people have dabbled into infrastructure as code? And this is not just CloudFormation. We're talking like Terraform and stuff too. Is anyone using CDK? Good. I don't like the CDK. All right, so again, CI/CD processes. This is all subjective. I'm giving you ideas. But I'm going to reference some of the ways that I've done it in the past. I'm not telling you that my ways are correct, but I'm going to talk about some of the ways I've done it because it's the best reference I have. So in source control, whatever I'm using, I tend to always treat the main branch as the production branch. If I want to make updates and do changes, maybe I'm doing a feature, maybe I'm doing a bug fix, whatever, I'm going to branch off of that. And I have now this working branch with all of my changes. And when I'm ready, then I will merge that back into the main branch. So when I'm working within my feature branch, it's kind of up on me to make sure that, conditions like linting, unit tests, or just formatting, whatever, like that's kind of on me because I'm working outside the main branch and, I'm adding or changing things. And there are some things that you can do to help, enforce code quality at this level, like pre-commit hooks. Pre-commit hooks are where you actually have things that will run like checkers when they try to do a git commit, and then it'll stop them if none of those checks pass. There's value in it. Some people get annoyed by it because it stops them from just doing things. So kind of you want to be able to just work quickly inside your feature branches. But then this point right here, where I'm merging back into main, you should not just be merging into main. This should be a pull request. And a pull request is going to be the first point in our automation where we can actually enforce some guardrails. The important thing about the way that I approach source control, no code should make it to the main branch that doesn't pass every single check that I want to enforce. All right, so we do have two options here in the context of GitHub and AWS, right? We have GitHub, which the core product is code repositories, and it is arguably the gold standard. And as we just saw earlier, everyone in this room, besides Tom, is using it. You opened yourself up for this, so just... Do you want to be my new target? Awesome. All right. I have to ask, though, is anyone here using code commit at all directly? So we probably aren't using code commit for our day-to-day work and operations. But code commit does have one distinct advantage over just GitHub for source control, which is it's already inside the AWS account perimeter, right? It's already within the security boundary, and it's already integrated into everything else. So there might be something to that. All right, so now we're going to get into the portion of the presentation where we actually start looking at scenarios of start to finish, GitHub to GitHub source control to deployment, how we might be using some of these services to create a CI/CD process. And the first scenario is that our code is in GitHub. There we go. We completed the first portion of this source control scenario. The second scenario gets into that idea that code commit is already inside the AWS account perimeter. Nobody really wants to work with code commit directly usually, so maybe we just want to make it so that everyone's working in GitHub, but then when it comes to the rest of the CI/CD process, we want to move the code into code commit as soon as possible so then it's inside the security boundary. So in this case, this pipeline is going to need an IAM role, which it's going to look almost identical to the one that we just saw with two exceptions. One is it'll use that string-like swap out I talked about to make it so that any branch is allowed to assume that role as long as it's from this repository. And then the other is instead of an S3 permission, it's going to contain code commit permissions. And this is going to be achieved through a GitHub action, this sync process where everything that's happening in GitHub, we want a replica out in code commit. So let's dive into that. This is one example GitHub action that is for syncing code from GitHub to code commit. Now, the on trigger here is on push, like we saw before, but it's saying specifically branches. Because a push could also be a tag. And you don't want to trigger this on tags necessarily. You're just doing a pure git sync. So anytime there's a push to any branch that happens at all in this repository, you want to trigger this workflow. And then we have this here, and I actually alluded to this earlier. We can give our jobs permissions. So in this case, I mentioned ID token earlier. This is where the GitHub action is going to tell the GitHub service, I need an identity token that I can send out to wherever in order to actually like get something back. It doesn't really care. GitHub, the service doesn't really care too much where that token is going. It's just going to generate the claims, sign the token, hand it to the workflow, and then the workflow will take over from there. Because remember, the establishing factor was the trust. That was done in the AWS account. Like GitHub was set up as a trusted third party. So that's where that validation is going to come in. The other permission here is we have to give the workflow permissions to read the repository that triggered it in the first place. So contents read, we are giving it read access. There is also contents write, so that way you can do things like make commits back if you are getting into that, or potentially working with releases. And then you can also like deny everything explicitly by saying contents none. All right, first step in this job is it's going to get a copy of the code from the ref that triggered this thing in the first place. And since this is just a sync operation, like we don't have to sync the entire history, we're just, whatever the latest commit was that did this, there's an optional fetch depth argument that I'm setting here saying, fetch depth 0, don't get anything else besides a snapshot of it at this commit, and I'm going to sync that. Now, this is interesting. Now we have a new action, which is the AWS credentials, configure AWS credentials. And I have to give it the region it's going to talk to, and then I got to give it the name of the role that it's going to assume. So this will call out to AWS. It's going to get that ID token, so that ID write permission. This action is going to tell GitHub, give me a token, and then it's going to take that token, it's going to call STS assume role with web identity, and then if all the checks and everything passes, it will configure the environment variables for the rest of the job with the AWS access credentials that are short-lived, and then the rest of the operations can just work without having to pass around any secrets. That's what this action will do. This action uses the AWS CLI, which will pick up those environment variables automatically. So I'm using this sync up to code commit action, giving it the name of the repo in code commit, and then the AWS region where it is, and then it'll just do it. Now, this is actually the second action in this that wasn't prefixed with actions, which means these aren't official GitHub Marketplace actions. So these are public actions that have been put out there by other users, other organizations, and they are just freely available for us to bring into our workflows and then start using them. Everything that is an action is a publicly available GitHub repository. So you can go and browse the code and see exactly what it's doing. Like with this one, this is it. Here's the script. Right? It is actually just setting up a credentials helper for the Git command line. And then it's going to get credentials for a code commit. And then it's going to sync it up. This is actually pretty simple. Like if we really wanted to, because we didn't want to rely on an external action, we could just copy and paste this chunk and put it into a multi-line string for the run command, and we're all good. But, you don't have to do that. This is available, it's out there, and it saved us a lot of work up front with just having to figure out how to do this. So, moving on from the source control phase, now we're going to go into the build phase. And this is also, again, where a lot can happen, not much can happen. It depends on what you're putting through your CI/CD pipeline. If you're working with code, it might need compiling. But a lot of code that we use, like Python, doesn't compile at all, right? It might need to be transpiled. Like, who's using Pickle? There are no brave souls in this room using Pickle. At Mac DevOps, I had somebody using Pickle. So Pickle is Apple's fancy configuration format where it actually will take their format, which has a lot of typing in it to prevent you from making mistakes, and then output it in different formats like YAML, JSON, and XML, or plist format. So maybe your build step is actually performing that transpiling. Code could also just be markdown files. Maybe your documentation is in source control and you need to convert it to HTML or something. The whole point of the build phase is not what it is, it's the outcome. And the outcome is that we have an artifact that we can then move on to the test phase. All right. So on our first one, on any commit to the main branch, we want to trigger a GitHub action that will then perform the build and then store those artifacts in, say, GitHub releases for now. If we're trying to keep it all inside the GitHub ecosystem, releases is kind of the one place where you can store built files that aren't in source control. And there's probably better ways of doing this. Like, I understand it's just examples. So here's a new workflow for running this job. Did I just back out? All right, good. So new thing here, as I mentioned before, if we need to write back to the repository, we need to be able to have a write permission, and the releases fits under that, that contents write permission. So this is a cheat, but like a lot of us probably have like a number of steps that go into whatever our build or prep phases for like what's in our repository, especially if it's compiled code. So usually those complex argument chains or multi-step instructions, they're inside a makefile or in a script, that's in the repository anyway. So like the point there is not so much that like I'm cheating by just saying make build. Like the point is just that like at this step, once I've checked out the commit that happened when we pushed the main, I then want to actually do the build, whatever the build is. And if this fails, the rest of the workflow doesn't run, which is an important thing to think about when you're designing your workflows, but like what steps have to be in what order and what the failure states are going to be. Like you want to fail early as possible, and not like waste compute doing things like if the code is in a bad state that's not going to actually complete. So for the sake of this example, I'm assuming that my build script actually outputs the version of what I was doing into a little text file. And this is to demonstrate the ability to take things that are happening at runtime and then plug them into environment variables so that you can then use those values in later steps. And then there are other options to actually make them available across jobs, because generally most variables are only available within the scope of a job unless you do a little bit of extra work to make it available to other jobs. So in this case, running a little command here. This is documented GitHub syntax on how to do this. I'm echoing out like version equals and then some substitution to cat that file. And I'm storing it inside GitHub end, which is an environment variable destination. And then down here with this other marketplace action to actually do the release, because GitHub doesn't maintain a release action anymore. They just point to other community options. I am going to take the artifact zip file that was output by my build, and then I'm going to set the tag to be the string from version.txt that I stored in the environment variable. Now in the pipeline down here, we're already inside AWS, so that push to code commit can automatically trigger code pipeline, or code pipeline will periodically check code commit for changes, and then it will pick it up, and then it'll just start running. So here's that pipeline template that we were looking at earlier. Changed out the source. The source is not S3 anymore. The source is now code commit. And if you don't want, so by default, it polls. Like the S3 option you saw before, this one, if I don't actually do anything, it's going to poll for changes. I don't remember what the time interval is, but with a little bit of extra work and configuration I didn't want to get into, you can still do triggers so that like on a change in S3 or on a change in code commit, you can just invoke your pipeline and have it go immediately. Because remember, the source stage, when the pipeline is triggered, it pulls whatever the latest version of that was. It doesn't actually look for a specific commit that you pass to it. You tell it, run, and then it goes and grabs it. And then, once again, we're calling the build. It's unchanged. And code pipeline is just going to take that source artifact, which is a copy of the repository of that commit, and then it's going to pass it in there. And then at the root of that should be our build spec file, which This is about as minimal of a build spec file as you can possibly see. Actually, it could be even more minimal. We can just say no artifacts. But like I said, there's only 4 phases available inside a build spec: install, pre-install, or install, pre-build, build, post-build, and then whatever your scripting in there is going to be. They really aren't as flexible as GitHub Actions when it comes to that, but that's where we get into the ability to have multiple build spec files if you need to have different build jobs running inside CodePipeline. So it's going to run the same make build that you saw over in GitHub Actions, but except it's then going to say the files that you're going to pass back as the artifact is this artifact.zip file. So then code build runs, and then CodePipeline knows that the output, that CodePipeline will then capture whatever the output was that was defined here, and then it will store that for whatever the next step in the pipeline is going to be. If you're going to ask a question, I have to pelt you in the face with the facts.
What's the environment look like for these commands? Is it a Linux environment? It doesn't look like you can specify that.
So that goes back to the project.
Okay.
So the project that you saw earlier in the CloudFormation template, that's where you define the running environment. And then, here, let's go back here. So you see where it says project name there? So like, if this was all in one pipeline template, what you saw that snippet where it defined the code build project, then you would actually reference that here, or you put the hard code name of it here, but you should never hard code names of CloudFormation. And then that's where it says, okay, I'm going to actually invoke that project, and then that project will just look in the default location for the build spec and just run that.
Thank you.
All right. So our first pipeline so far is operating entirely within GitHub. And our other pipeline is offloading to AWS as early as possible, and is giving up some of that, like some of those nice things that we can have with GitHub workflows. One is leaning into the GitHub developer experience entirely, and the other one is leaning into the AWS ecosystem and security model, almost entirely. But there's a third scenario that kind of sits somewhere in between that I'm going to talk about at a lot more length later on, that tries to leverage the strengths of both of these. So in this case, this third one, what it's going to do is it's going to leverage GitHub Actions earlier on and do a lot of the work there. And then where we have code build here with the build of that lower pipeline, that kind of is happening already up here in that middle pipeline, and then it's sending the artifacts off to S3 to actually be delivered. So we'll get into more detail about that towards the end. All right. We're now moving on to the test phase. And we have artifacts from our build. We need to validate those artifacts now. Like, they passed some, they got merged in, they passed the builds. Now we need to test them. This is the second half of the continuous integration piece of the pipeline. So first half was the source and build. Now the testing, that's the second part, that is the second half of continuous integration here. And again, depending upon what you're doing, this is going to vary wildly on what your implementation actually looks like. For code, unit tests, integration tests to some degree, that might be what you're running here. Configuration files, infrastructure as code files, like linting validation of those, schema validations, things like that. It can take all sorts of shapes. But whatever happens here, the outcome must be that you have a verified artifact that is production ready. You have to have confidence that once it passed this phase, this artifact is ready to go into your production environment. Now, you might be wondering, because we're already pretty deep into this, where are those tests? So in most cases, you can kind of combine the build and the testing phases into like one operation. CI/CD has phases to it. But that doesn't mean that those are unique individual steps that you adhere to. Sometimes they blend boundaries and they are out of order maybe, but the point is that they are there in your process. And in this case, it makes a lot of sense really that the build and test kind of happens together, because if you build something, you want to verify it first before it goes out into storage somewhere for the next part. So if you're compiling code, you have to run a build before you can do those tests. If you're using interpreted languages, you'll probably have to install dependencies before you can even run any of your tests on those. And again, for things like YAML and JSON files, you're probably going to do schema validations and linting on those. And something very important to call out here is these two pipelines right here, the first two. GitHub Actions can be tied to pull requests. And if you tie them, and not just when a push to main happens, but like on the pull request itself. And when you do that, they can be required to pass before any merge is allowed. And you probably have all seen this like on a lot of open source repositories all over the place. They may not be using GitHub Actions, but there will be like external runners or things like that that are integrated into the pull request, and they'll say, oh, this is failing, and it'll block merging. Like I said earlier, when I'm doing code, main is the production branch, and no code should be allowed to merge into that doesn't pass all validation and testing. And this is the magic box right here to make that happen. This is located in GitHub, so in your repository settings, code and automation, branches, branch protection rules, you would create one that matches the name of the branch that you want to put safeguards on, and then it's in the protect matching branches section. You check this box, and then make it so that the trigger is on pull request, and that's all you need to do. And all of a sudden, this GitHub action is now a status check that must pass in order to allow merge. So this is actually an example workflow that I've adapted from a Python package that I have out there. This is what runs on pull requests to the main branch. The trigger here is saying pull requests only on the main branch. It won't run these checks on every single branch that appears or pull requests between branches that aren't main. I don't care about those too much. I care about ensuring that like there's a hard stop for anything going to the main branch that isn't passing the tests that are established. Again, contents read permission, but it's in a new place. It's actually at the workflow level. So you can set permissions at job level so that some jobs need more permissive permissions than others. So you might do it that way. But this is actually half of that GitHub action that I was just talking about, because there's a second one where I'm experimenting with integration tests. Both of those things need, or live integration tests is what I should say. Both of those need read permissions. So instead of repeating that code block across both jobs, I just put it at the workflow level because everything is going to need read access to the repository. So here I'm using the setup Python. In GitHub's example, they were doing setup node. Setup Python works the same way. I'm saying with this version, 3.9 is the minimum version this package supports, so that's what I target when I'm doing these tests. Then I'm going to tell it to install the package locally. It'll pull in all the dependencies, set up the environment, pull in all the dev dependencies too. And then it's going to run two sets of checks. It's going to run all the linting and all of the, what does rough do again? Oh, yeah, rough checks for, black is checking code formatting, rough is checking linting rules. Those have to pass, and then it'll run PyTest, and all those have to pass. If any of this fails, it's going to put that red banner on the pull request and block it from merging. And that little vertical line you see there is me using YAML syntax to do a multi-line script. Like, I could break those up across two separate runs, but in my head, these are both linting related things, so I just kept them as one step. All right, so the build. So there's the build. We test and validate the artifact. And that's pretty good. Like if the artifact passes that point, then okay, we've done a lot of our sanity checking. But, and this is a big, it depends. You might need to actually do additional testing on that output artifact. Like it might be good, but you might need to do more rigorous testing that actually involves things like no mocking of anything. It might require talking to live services to actually validate it is doing what it's supposed to do. This all comes down to what you're doing and how sophisticated of an environment you have. Like some of you might be lucky enough to have a test environment that's not production. So you might want an additional phase after that first build and test where you actually send it out into the wild. So we're not going to get into actual YAML examples of these, But like this would pretty much be another example where we're going to trigger off of wherever that built and tested artifact ended up, we then trigger the next phase automatically. In this case, this would be a GitHub action off the first pipeline looking for new published releases. Once a new published release happens, we probably want to send that out into our, legendary test environment to actually run live and tell us that everything is fine. In the second pipeline, as soon as that built and tested artifact hits S3, same thing as like the other one, like we want code pipeline to automatically trigger, and the first thing it could potentially do is run a code build job with a build spec file that actually handles like putting those artifacts through live testing within the AWS account if it needs to talk to AWS resources, for example. And then really it's kind of the same thing down here. Like code pipeline is handling the artifacts. So like the artifacts are in S3 and code pipeline is really just going to move on to the next phase, which could be another code build job, a CloudFormation step. It could be something that is then performing that next round of testing. And again, like whatever you have available for testing environments is going to dictate kind of like what you're going to do once you hit that point. Or you might not do a secondary testing phase like that at all. It is a really big it depends. So we've now reached the point in our CI/CD pipeline where we have validated artifacts and we can deploy them. All right. So, and just like, that mythical test phase that we just went through and then like, the actual build steps, like, again, it all depends on what you're doing. Where is it going? How do you need to deploy it? And, we have Terraform users. So like your deploy step is probably going to be calling the Terraform command line tools and then, sending those things out into the wild. How many here deploy things with scripts? There is no shame in that, Don't let anyone tell you otherwise. But like scripts are valuable, scripts are repeatable. Like your deploy process could be a script. What matters is whether or not it's you sitting at your computer pushing a button that versus an automated process where it hit the script after it did a whole bunch of other pre-checks. Again, code build, I kind of just talked about that. Like if you have, and then CloudFormation, if you're like me and you use CloudFormation, not many of us use CloudFormation, but like, there's a whole bunch of deployment options. In the AWS context, code build is probably what you need if you're going to be going to Terraform or if you're going to be using a script deployment method because you need a runtime environment that's going to run automatically in code pipeline, and that's really going to be code build. And now finally we get to the part where the AWS permissions thing I talked about all the way at the beginning gets a little more serious. So in this first one, if the GitHub action is going to be deploying to anything inside AWS, it's going to have to be able to assume a very permissive IAM role, right? Because it's going to need to be able to read, write, update, and delete resources in AWS based upon like the template or the Terraform template even. Because Terraform, if you're using Terraform for things in AWS, then it still needs IAM access keys in order to go do all of those things. So it's still the same problem. You have to have a very, very permissive IAM role that you are allowing an external service to assume that has near administrative rights to a whole lot of stuff. The permission story kind of dictates what happens at this point. If you're not doing it in AWS, it's a little bit different, right? If your code's going somewhere else and it's talking to APIs of something else, well, you still have the same problem where you have to store those secrets in GitHub. The benefit is that the AWS credentials are going to be short-lived, but you are opening it up where there is a compute runtime out there where if you can get something through to the main branch, it'll be allowed to assume that. And the thing is, like these last two pipelines, it's the same thing. Like they are going to need an IAM role to talk to anything inside AWS that is administratively permissive, except, again, we're already inside the AWS account perimeter, right? The permission story is a bit different if you have AWS compute and services running inside the AWS account and then assuming roles in there. Like it's not leaking outside the account boundary. So yeah, if you are deploying somewhere besides AWS, like odds are you can just stick entirely within GitHub Actions and the GitHub ecosystem and just live comfortably right here. But we're going to stop discussing theory for a little bit. So we're at 21 minutes, nice. To close this out, I'm actually going to focus on this middle pipeline here because this is my pipeline. This is what my teams over the years actually implemented for most of the things that we built. And those were all AWS services. Those were APIs that were running in AWS. And this is how we implemented CI/CD. And we're going to deep dive into that. So very first thing that happened with all of our code repos, and we had like 20 or 30 repos of different services and stuff. This was kind of the shared thing. Like we ran automated tests on every single pull request to the main branch. Now there's also something interesting here because we kept documentation for those APIs in the same repository, but we didn't really want to trigger the unit testing process if we were just doing documentation updates that didn't affect the code. So we actually set ignore paths for anything that was a markdown file or reside in the docs directory. It didn't run this. We could do pull requests to do documentation fixes and pushes independent of actually like accidentally triggering a service deploy. And then, the rest of it's kind of like the standard boilerplate you saw before, pull in the code, set up Python. But then down here, we used pipenv for maintaining all of our dependencies in these projects. It's a dependency management tool for Python. Poetry is, I think, more popular now, but we standardized on pipenv for all of our stuff. So we would have it install pipenv. We would then sync all the dependencies, including the dev dependencies, purely for testing. Then we would run linting across all the CloudFormation templates that were in those repositories. Then we would run the format checkers. And then we would finally run PyTest after that. All of this had to pass before anything was allowed to merge into the main branch. And then once it did get into the main branch, not one, but two different workflows would then trigger. So the first one was the actual upload to pipeline. So you saw on that one slide how it's like, okay, from GitHub Actions, we're going to go straight into S3, and that's the crossover point for our accounts. That's what this did. So again, this leveraged that role assumption. It would go out, it would assume a role. That role gave it access to upload to just one spot in an S3 account. And that bucket, or S3 account, an S3 bucket. And that bucket was set up for versioning, so that way, even though it's the same name every single time that's getting put to, it would just increment the version inside S3, so we could backtrack through artifacts if we really needed to. The role name, we actually did store in AWS Secrets Manager, just so that we wouldn't have it plain texted. And then afterwards, I skipped that. We didn't actually maintain the dependencies at this point. We actually would just zip up the repository because something else would have to happen once it crossed the account boundary. But then it would finally upload to S3 at that path. The path we also kept in secrets or GitHub Secrets, so that way it wasn't plain text. And that was it for this. The other workflow that triggered on every push to main was our documentation updates. This one I left in there because what do you think workflow dispatch does for those who don't actually know the answer? This one line here is what lets you get a button in GitHub to manually run your workflows. Very, very handy if you're experimenting with things and like you are having failures because you misconfigured something, not because there's a problem with your workflow file. Or if you just want to release changes, even though you don't have a code change, you want to release it because it's going to go install newer dependencies maybe. New permission here. We used GitHub Pages for all of our API docs. So this workflow actually writes to GitHub Pages after it builds the documentation. And again, this should all be feeling pretty standard now because you're seeing a lot of repetition in all the GitHub actions I show you. It's checking out the code. It's calling a GitHub action for configuring pages. And there's a lot of like hand-wavy magic going on because GitHub is like doing a lot of steps for you for prepping that. Then it's going to build the docs. And in our case, there were two different kinds of docs that would get built. One was a markdown file or restructured text-based, depending on which documentation system we were using, it would convert those files into HTML, so we'd have nice HTML documentation. And then the second one was using the Redux CLI to actually generate from our OpenAPI spec an API document that would be embedded in a path inside the other documentation. So that's all happening there. And then it's output into this build docs directory, which the next action just handles the upload into GitHub pages for us. And then it'll trigger the deployment. And then boom, the latest version of our API documentation is now available for others in the company who were interacting with those APIs. And because, again, the automated unit test workflow was only looking for code changes and it was ignoring anything that could possibly be a documentation file, we actually did a whole bunch of pull requests that were just documentation updates and fixes for things that people didn't understand, or somebody said, hey, you made a typo. So now we get into code pipeline, because that upload to S3 action, that zipped up the contents of the repository and handed it over. You were kind of asking about this a little bit ago. So code build project is defined above. In this case, we were still doing x86 runtimes for everything, so that's what it's set up for. We skipped over a S3 bucket that's used by the pipeline for storing artifacts and passing them around. The source for this one is S3, and it's looking for that specific path that was being uploaded to from the GitHub action. So bucket name /sources /main.zip. That's what it's looking for. Every time this zip file gets updated, that will cause a trigger for the pipeline. You'll see here that pull for source changes is turned off. I'm not showing the CloudFormation for it, but this is a pipeline where we did set up that event notification where on a change to this key, go trigger this pipeline. It's not a whole lot of extra configuration in this code, but didn't need to cover it too much in here. So it's going to output that as a source artifact, and then our first build is going to, and not first build, the only build is going to happen where it's going to call code build. It's going to run that project that you saw before. And this is the build spec file that runs in there. So the things that my teams were building were all serverless applications. They were serverless APIs, right? So they were all running in Lambda with an API gateway in front of them. So we were using a tool set called SAM for that, which you probably have heard me talk about in the past. Here we're finally using some more of those phases for the build spec. In the install, I'm configuring my runtime. Then when we get down here, we're using the SAM tooling to actually perform a build operation. But what SAM is doing is a little different than what I was kind of talking about with the other pieces for builds. What it's actually doing is it's based upon the template, it's bundling together a bunch of Lambda functions for the code and any dependencies that they might have had that are external dependencies, and creating zip files for all of them, and then uploading them to an S3 path. Or not uploading to S3 yet, sorry, but it's creating all these bundled zip files that contain all the code and any dependencies, and that's the Lambda function artifact. And then in the post build, once that build process is passed, because pip is getting called in that, so maybe there's a problem with the dependency in there, and we're going to kill the build job if it doesn't pass that step. In the post build, that's where the packaging happens. And for packaging, what that's doing is it's taking that template that has all those zip files referenced in it that it just created, it's then creating a packaged version of that template, which is it's going to upload all those zip files to S3, get what their names are in S3, substitute those into the template, and now we have a CloudFormation template that is ready to hand over to CloudFormation itself, and all of the code artifacts are staged. And the only artifact that's output from this code build job is actually those packaged YAML files. The reason why you see the syntax like this is because we would actually have two versions of this build spec. One for a single region deployment like this, and another where it actually, in the environment variables, we would set, these are all the regions that you're actually going to be packaging for, and then it would just loop over them all and package that thing for every single region, and then we would have 3, 4, or 5, 18 in one case, templates that we could then do a global deployment with. And in our case, because it was all CloudFormation, the deployment phase after that was actually just calling the CloudFormation action, passing it in that artifact and the name of the template file in there. And then our stacks would update with the latest code change. And we had this completely automated. We never actually touched any deployment mechanisms ourselves. And there are actually some additional complex versions of this that I'm not getting into. So remember when I said maybe after your build phase, maybe after your build and test phase and you have that artifact, you might go on and you might have a more intensive test environment afterwards. So in our code pipelines, we actually, if we were doing multi-region deployments, we actually might have a canary region. So our stack changes actually go into the canary region first, and it waits. And we could actually run tests against that first, and then as long as those passed, then it would move on to deploy to the rest of the AWS regions or accounts and regions that we were actually sending that out to. So this was what my teams, for the most part, kind of opted into as implementing our CI/CD pipeline. We wanted the benefits of GitHub's developer experience and being able to have the GitHub workflow files in the repository, being able to enforce code quality, enforce testing percentages and gatekeeping on a whole bunch of other things, and make it so that our, oh, that's not applause, that's rain. I thought that was another room. We wanted to make sure the code was in the absolute most stable state that we could be assured of, and then let the rest of the process happen, and then still include additional checks along the way, so that way if something slipped through, we didn't cause an outage because it was actually in a canary region first. We could let that be bad while we fix the problem and then roll it forward, which was another thing about our CI/CD process. We tried very hard not to have rollbacks. We wanted it to hit that canary region, test the canary region first, and then if there was a problem there, nobody's using that. That's where we discovered the problem, and then we'll fix the changes, and then we'll have the process restart, apply to the canary region, restart tests, and then roll forward to production. And also, there was the added benefit of the fact that all the deployment bits were happening within the boundary of our AWS organization and our accounts, and we weren't granting access to very permissive roles to external services. So as far as CI/CD pipelines that you consider, the whole point is that there are 4 distinct phases when it comes to a CI/CD pipeline and process. They aren't just like I have a source step and I have a build step and I have a test step and I have a deploy step. You might have multiples of those, and you might combine them at certain points, but all of those should be present, and you should have the whole thing automated because human interaction is what inevitably leads to error a lot of the time. So automate as much as possible and try to fulfill all the requirements of that. So thank you, and we have time for a little Q&A here. We got 8 minutes, not bad. You have the catch box. We have a question over there.
Thanks. What did you say you were using for documentation?
So I've used a bunch of stuff over the years. This was years ago, before MKDocs was really as cool as it is now, and we were using Sphinx. So Sphinx for like all of our hand-typed user documentation, because my teams didn't just believe in throwing an open API doc at someone and calling that docs. We actually wrote user documentation about how to use the APIs, and then there was the API spec document, which open API file, translate into that nice little browser that you get for. So those were 2 things. One, Sphinx was our user docs, and then we used Redoc or Redocly. I'm not sure what they call it now. I think it was called something else before, and that is a command line tool which will take an open API file and generate HTML documentation from it. Also, if you go look at the Jamf Python SDK's documentation, that's all markdown files using MKDocs. So every time I push to main on that project, it actually is rebuilding using MKDocs and then publishing that to GitHub pages.
Thank you.
Lots of ways to approach documentation. But, and this was a talk I think I did back at Macaduck back in 2018. Like, it's best if you try to keep your documentation and your code together in one place, because then if someone is reviewing your pull request, they can say, you made these changes and I don't see any doc updates with it. Documentation is king or queen. Any other questions? Hold on.
I'll pass it to you in 1 second. If someone is using GitLab, how different is it from what you were showing?
I think GitLab has something similar, and you actually, I was teasing earlier. I'm teasing you, Tom. Like GitLab actually does have parallels to a lot of things you see in GitHub Actions. To be frank, though, GitHub Actions have gotten really, really advanced and really, really robust. Like you saw with CodeBuild. CodeBuild has been around for a long time. The build spec format is kind of showing its age, and it's very much a AWS developer-centric designed build service, and that's kind of like the mindset it's in. GitHub Actions are extremely flexible, and you can do all sorts of weird stuff with them. And Tom, were you going to talk a little bit about GitLab's thing, or you got something else?
I can't have a question for you, though.
Let's do both.
On your back end, like your infrastructure, I'm assuming you're using like remote runners and EC2s and maybe various operating systems. Maybe a secrets vault. Can you kind of like maybe just go over kind of like how you approach building out the infrastructure in a way that, one, it makes sense, and two, you're using like a security first kind of practice?
So, story time, because I got 5 minutes. So that pipeline I just walked you all through, that example, that wasn't actually a pipeline for like one of the main services that my team worked on. There was a reason why it was only single region. That pipeline was for the pipeline management service that we built to actually further automate the CI/CD pipelines for everything else that we did. So what we actually designed and came up with was, and again, when I said earlier that we used webhooks for some things and you can use those, we actually built a pipeline management service where we could register a repository, and it would generate a single IAM role only for that repository with an upload path for that repository for it to zip the contents, send it to. And then you just told it which accounts and which regions in those accounts and what order you wanted that stack to eventually deploy to. And then it actually managed the code pipeline, code build, and all the other stuff for you. So we were getting sick and tired of copying and pasting pipeline templates all over the place that were 99% just the same stuff over and over again. So we centrally managed that. It allowed us to also better increase the security story, because like you had to go to the service and it would generate the role for you, and you had no access to any of that stuff. You just plugged those values back into GitHub secrets for the things that were being pulled in that you didn't want to plain text in GitHub. In AWS, we leveraged Secrets Manager for, well, I'm not gonna talk. All right, so I'm not gonna talk about Secrets Manager actually. For the most part, we did use Secrets Manager for a few things, but mostly it was encrypted SSM parameters. So if there were values that had to be pre-staged, normally what those teams would do is like the CloudFormation templates would pull in those at like deploy time. So they would actually and they generally had access to some of the accounts that we're going to. It's just that our system was managing the CI/CD components. So you would use parameter store or Secrets Manager if it was especially sensitive to actually stage those values, and then you would have that in your templates, and then CloudFormation would resolve everything. And then if you had to rotate any of those values, you would do that, and then you would tell the pipeline release, because you need to tell CloudFormation to go pull in the latest values.
So then you're also using SSM to manage all of your CI boxes?
So we tried really hard to avoid EC2 as much as possible, because the moment you touch a virtual machine, you inherit a lot of responsibility. We used, honestly, man, like the code services that I outlined, you don't touch EC2 actually. So like code build, like I got 58 seconds. So like you saw that, like you give it a compute type and then a container to use, and like code build is handling the compute runtime for you. So like we tried really hard to not take on responsibility for things that we don't care about. And in fact, again, if you're not getting into custom runners and GitHub Actions, GitHub Actions are an enabler because they allow you to go really fast and not care about patching things when all you want to do is to deploy stuff and build your code. Try as hard as possible to use managed services with whatever provider you do have, because you can probably justify the increased cost by the amount of time you're not spending patching everything.
Anybody else?
10 seconds. Who's got a good one? All right. Everyone, thank you for coming and listening to me talk about YAML.